All right, guys, here we go. Lesson number 3 of the day. I know what you're thinking. She's really making us do 3 lessons today? Well, if we're being honest, the first 2 were pretty short. All right, so this one's going to take a little bit of time, but it's not difficult. It just we have to go through the steps, okay? So we've already talked about a quadratic equation. There's your first blank. Quadratic equation has degree of 2. Remember we talked about how is this different from a linear equation? Okay, well remember a linear equation only has degree 1, meaning it's only x, whereas quadratic is x squared. Okay? So each term in a quadratic equation has a specific name. We talked about this yesterday. And we're going to use the vocab words when we talk about them. So we talked about that this term right here is called the quadratic term because it has the 2, right? This is called the linear term because it makes a line because it's degree 1. And then this term is called the constant term. All right? Okay, so if we look at these equations and we practice labeling which one is which, if I ask you which is the quadratic term, you would all say x squared. If we look at which one is the linear term, you would say, good, negative 10x. And the constant term then would be 3. Alright, what about the second example here? Our quadratic term, even though this is out of order, it's still okay because we can identify which one is which. Remember the quadratic term has the square, so it would be 2p squared. The linear term, negative 15p. And then remember our constant is the one that doesn't have a variable with it, so it would just be 12. All right, what about the third example? Does anyone see that there's something wrong? It's not set equal to 0, right? And we talked about yesterday, every time that we talk about quadratic equations, they have to be set equal to 0. So what I need to do is I need to move the 3 over. Remember, we want to keep the quadratic term positive, and it's already positive there. So that means I'm going to move the 3 over this way. So really my equation would be 0 equals 3 minus 9a plus 5a squared. So our quadratic term here would be 5a squared. The linear term would be negative 9a, don't forget the negative, and then the constant is 3. Alright, questions on that? Haha, I can't hear you. Maybe you can ask your neighbor if anyone has any questions. But that's pretty straightforward, and again, we talked about that yesterday. Alright, oftentimes you will have to evaluate a quadratic function given a specific input. So, for example, if we're looking at number 1, it says evaluate f of 3. Now, we haven't really talked about f of x yet. It looks new to you and maybe a little bit scary, but all f of x really means is f stands for function of x, all right? Because would you agree this equation is given to us in terms of x, right? So this is the function of x. So really, we could just substitute it in to just be y if you want to think about it that way. I don't want you to cross it out, but I want you to think of it. F of x is just a fancy way to write the letter y. We're in Algebra 2 now, so we're stepping things up a notch. So f of x, whenever you see it, it just means y. Okay, so it's not really anything new. It's just a more correct and accurate label. So when it says evaluate f of 3 for f of x equals this whole equation, what that really is asking you to do is if we put f of 3 right underneath this, that means wherever there is an x in your equation over here, we want you to instead put 3. So this would be 2 times 3 squared minus 5 times 3 plus 10. So you can see that wherever I had an x, here and here, I put in the 3. Now be careful here, it should be x squared, so it needs to be 3 squared. Not 2 times 3 and then squared, but 3 squared. Okay, so then we just evaluate, which just means solve the right side of the problem. The left side is going to continue to just be f of 3. All that is just a label for the problem. Okay? So I have 2 times 3 squared is 9. 5 times 3 is 15 plus 10. So again, we're going to put our label on there, f of 3. 2 times 9 is 18 minus 15 plus 10. F of 3. 18 minus 15 is 3, and 3 plus 10 is 13. So what this means is when we plug 3 into this equation at the top, we should get 13. So the input is 3, the output is 13. And then this would be your final answer. Notice it is not f of x in our final answer, because f of x is not 13. F of 3 is 13. Okay? Why don't you go ahead and try number 2. I'm going to clean this up a little bit while you guys try number 2. So the first thing I always like you to do is just to write it in there. So remember, the left side of the screen isn't going to do anything. It's just the label. Alright, so h of negative 2. We know that negative 2 squared is 4. And then, so I'll have negative 4 times 4. And again, you can do some of these steps at the same time. I'm just writing it out so we don't lose anyone. 7 times negative 2 is negative 14 minus 1. Negative 4 times 4 is negative 16. And then if I were to combine all those together, I'm really adding because they're all the same sign. That would give me a negative 31. Don't forget your label over here though. H of negative 2 equals negative 31. And that is my answer. Alright? Any questions? I should probably stop asking that since I can't really hear your questions. Alright. Alright, we again have talked earlier that the graph of a linear function, what does it look like if it's a linear function? Well, we said it looks like a line. But then we have the graph of a quadratic function, and that is called a parabola. Remember, it is not parabola, it is parabola. This is going to be a vocab word, by the way, parabola. It's the graph of a quadratic function. You should know that one. And then depending on the sign of the coefficient of the quadratic term, the u is going to go up or down. So let's talk about what that means. The quadratic term, remember, is ax squared, right? And this says it depends on the coefficient. So this depends on the sign of a. So if a is positive, the parabola is going to go up. If a is negative, the parabola is going to go down. Alright, so we can kind of count on those two things. Alright, so we stated that a parabola is the graph of a quadratic function. These are key terms. These are vocab words that you need to know. The axis of symmetry. Does anyone know? Heard of that? The axis of symmetry is the imaginary, let's make this red so you can see easier. The imaginary line that cuts the parabola in half to make it symmetric. And I'll talk about what that means in a minute. It is the imaginary line that cuts the parabola in half to make it symmetric. It is always a vertical line, so maybe we should add that in here, that it is the vertical imaginary line. It is also taking the equation x equals the opposite of b over 2a. This is really important for you to know. I would highlight this, star it, something. But you have x equals, oh, sorry, you can't see it on my graph, on my paper. The vertical imaginary line that cuts the parabola in half to make it symmetric. The formula to find the axis of symmetry is given by x equals the opposite of b over 2a. Seems very similar to other things that we've been doing, like opposite of b plus or minus b squared all over 2a. Very similar, okay? But it's just opposite of b over 2a. We could then say that the vertex of the parabola, I like to call it the starting point of the parabola. It uses the letters h, comma, k. As if it's a point, it's an xy point, right? But because the vertex is so important, they use the letters h, k instead. The maximum on the graph is the highest point on the parabola, or of the parabola. So the maximum is the highest point. That makes sense, right? Maximum. The highest point of the parabola is the maximum, which then means the minimum is the lowest point of the parabola. Again, I cannot stress how important it is that you know x equals opposite of b over 2a. That is hugely important, and it's going to be helpful to you as we go on. Okay, so kind of keep these things in mind. Every graph that we're going to look at has these things. Now, if you think about it, you actually have already figured out how to do the x-intercepts, right? We talked about that 2 days ago. Remember when the whole time you're factoring or solving, every time you do that, you're finding out where the parabola crosses the x-axis, okay? So keep that in mind. We're going to do that on Thursday. But for right now, we're just going to find these parts of the graph. All right, so if we remember, we have already talked about what standard form of a parabola looks like. I'm going to give you two different ways, or two different forms of a parabola. One of them we haven't talked about yet, but remember, standard form from yesterday is y equals ax squared plus bx plus c. Remember the quadratic term, the linear term, and the constant term. I talked about this a little bit on the previous page, but remember, what do we know if we know that a is greater than 0? Well, if a is greater than 0, that means it's a positive number. If it's a positive number, the graph opens up, right? So it should look like this. The parabola should look like this. And if the parabola looks like this, then that means I have a minimum. Can't draw that with this one. That's supposed to be a point there. I have a minimum. Okay, if A is less than 0, then it means it's negative. Okay, so if A is negative, that means it's going to open down, right? So it's going to open down. If it opens down, then it has a high point, or we would say it has a maximum. When we are in standard form, we need to find the vertex and then be able to graph. So when we are looking for the vertex in standard form, the first thing that we have to do is x equals the opposite of b over 2a. That's what we do first. And I'm sure you're thinking, well, I thought that's what we were supposed to be doing for the axis of symmetry. You are correct. They start off the exact same way. So when we're trying to find the vertex, we are looking at x equals the opposite of b over 2a, which is going to give us our x value. Remember, vertex is the HK thing. Really stands for an XY point, right? So when I do opposite of b over 2a, I'm finding the h value. To find k value, I then plug x back in to my equation, and we solve. We're going to do several examples so you will not be lost. But you need to star this somehow, that this is how we find the vertex, because students will start graphing and they will say, I don't know how to find the vertex. Well, opposite of b over 2a. Alright, so let's look at an example here. A couple things I want you to look at first is, what is our a value? Well, if we look at our equation, we know that a is 1 because that's the number that's in front of my x squared term. So a is 1, which means it's positive. And we just talked about if a is positive, then our parabola is going to open up. Then how do we find the vertex? Alright, so in order to find the vertex, remember we do x equals the opposite of b over 2a. And by this point you know where a, b, and c are in your equation, right? So a is 1, b is negative 6. We could write that down here. A is 1, b is negative 6, c is 11. Alright, so the opposite of b is going to be a positive 6 over 2 times 1, and 6 over 2 is 3. So that means the first coordinate of my vertex is 3. That's what that means. Then how do we find out what the second coordinate of my vertex is, or that k value? So what we're going to do is we're going to take this 3 that we just found and solved for, okay, and we're going to plug it back into the original equation. So I'm going to write, I'm just going to write the equation down, x squared minus 6x plus 11. But instead of x, we're going to plug in 3, which is why we did the first two examples about plugging things in. So 3 squared minus 6 times 3 plus 11. So again, we took this 3 that we found by doing opposite of b over 2a, and we plugged it in for x into our equation. So I get 9 minus 18 plus 11. 9 minus 18 is negative 9 plus 11. Negative 9 plus 11 is a positive 2. So that means the second coordinate of my vertex is a positive 2. All right, now, because the axis of symmetry starts out the same way, opposite of b over 2a, that means the vertex, the first coordinate of the vertex and the axis of symmetry are always going to be the same thing. Because the axis of symmetry is a line, it has to be an equation, because every line has an equation, right? So the axis of symmetry must be always x equals whatever the first coordinate of the vertex is, so 3. That would be your axis of symmetry, is the equation x equals 3. If you were to just put 3, it's going to be counted wrong, because it is not just 3, it is x equals 3. Alright, so now we have enough that we can graph. If you do not have a highlighter, there is a bucket of highlighters on my desk if someone wants to stand up and quickly pass those out. Who sits over there? Travis or Donquavius? If you want to grab the bucket off my desk, pass them out quickly. Everyone needs a highlighter. Perfect. All right. So what we're going to use our highlighter for is to draw our x and y axis on these graphs. All right. So with your highlighter, just draw a rough estimate of your x and y axis. Okay. And then we're going to graph our vertex. Remember, vertex is the point 3, 2. So that means I always go to the right 3 because it's a positive 3. So if this is my starting point, that's my origin. If I go over 3, 1, 2, 3, and up 2. We always label our vertex with a v3, 2. Always label your vertex. You get points on quizzes and tests for labeling your vertex. We know a parabola goes up, so we're just going to roughly sketch it up. And then we need to put our axis of symmetry in there. Remember, axis of symmetry goes through the vertex. It's an imaginary line. Because it's an imaginary line, we're going to dot it. So it should be a dotted line through the vertex, which then makes sense why it's the same number. The vertex starts off with 3, 2. So the axis of symmetry is also 3 because it goes through the same point. So then make sure that you also label your line. So on the side of the line, somewhere either at the top or the bottom, you need to put x equals 3. That is labeling your axis of symmetry. If we look at this graph, would you guys agree that it is not on the x-axis, which means these are what kind of roots? If it doesn't touch the x-axis, did you guys say complex? Right? Complex, which means there should be imaginary numbers in this. So if you were to solve this quadratic out, you would get imaginary numbers in your answer. Okay? All right, let's go on to example 2. I forgot to talk about whether the previous graph had a maximum or a minimum, but if it opens up, then that means that there is a low point, and so that low point would have a minimum. So that graph has a minimum. So go ahead and put that in the blank there. All right, example number 2. Our A here is -2, so we're going to go ahead and put -2 in our blank for A. If A is negative, that means the graph opens down. So our vertex, remember how we find the vertex here? Opposite of B over 2A, right? So the opposite of B is going to be -8 over 2 times -2. that means I have negative 8 over negative 4, which is 2. So that is, again, the first coordinate of my vertex. Do you guys remember how we find out what the y-coordinate or the k-coordinate is? Yes, we have to plug back into our original equation. So if I have negative 2x squared plus 8x minus 10, that's my original equation. And so I'm going to plug 2 in here for x, plug in 2 here for x. Alright, so 2 squared is 4, so I have negative 2 times 4, plus 16 minus 10. Negative 8 plus 16 minus 10, so 8 minus 10 is a negative 2. Now, if you are doing this and you get crazy numbers like negative 17 or something, for the most part, your vertex should never go off the graph that I've given you. So if it does, then you've probably done something incorrectly and you need to redo it. Okay? So the second coordinate of my vertex is negative 2. Remember, the axis of symmetry always starts off x equals, and x equals whatever the h coordinate of your vertex is, so x equals 2. Alright, so with your highlighter, okay, let's go ahead and draw our x and y axis. We're going to graph the point 2, negative 2. We're going to label. We know that this graph opens down, so I'm going to just do a rough sketch. Right now I don't really care where it's touching, just we're going to label it down. Please make sure your parabola extends all the way to the end of the graph and you're drawing arrows. Those are little things, but those are details that are important. And then the last thing to do is to draw our our axis of symmetry. And then to label it x equals 2. So if example number 2, if the parabola points down, then that means that there is a high point, so it has a maximum. So you can go ahead and fill that in that blank. Alright, but what if we're doing a problem and there's a certain term that's missing? So if we look at example number 3, which term is missing? You would say the linear term. Right? So the linear term is missing. And if the linear term is missing, then this means we know that the vertex will be on what? Well, let's investigate. Our A here is 2, which means it's positive, so our parabola is going to open up. Our vertex, we're still finding the vertex the same way. X equals opposite of B over 2A. Go ahead and find your vertex. I'll write it up here quietly without speaking. The problem is though, wait, what is B? It's not there, so it's really 0. And we know that 0 divided by anything is still 0. So I don't really have to keep going as far as finding my x coordinate. So I know that the first coordinate of my vertex is 0. And remember, we find the second coordinate by plugging 0 into our equation. So my equation is 2x squared minus 4. If I plug 0 in here for x, this is gone, right? So I just have negative 4. So that's going to be the second coordinate is negative 4. My axis of symmetry is still there. It's even though it's x equals 0, right? Because it's the same thing as my k or my h term. X is 0 is still a line and it can still exist. So let's go ahead and draw our x and y axis. I'm at the point 0, negative 4. 1, 2, 3, 4. I'm going to label my vertex. I know this graph opens up, so I'm going to draw, see how my parabola extends all the way. And then I'm going to draw a line down the middle, a dotted line. Now for you, you've probably, it's following on the same line, you might not be able to see it. So what you can do is you can extend it past the x-axis, or I'm sorry, extend it past the graph so I can see. And then on the side, don't forget to write x equals 0. So what can we conclude? If our linear term is missing, our vertex is going to be where? On the y-axis. You would agree that the vertex here is on my y-axis. Okay, so it's just kind of a shortcut. All right, why don't you try example number 4? On example number 4, does it matter that it's out of order? No, it doesn't. So I still know that a is the coefficient that's in front of my quadratic term, so I know that a is 3, which means it's positive, so it's going to open up. Vertex is still going to be the same thing, but we can notice here that it's missing the linear term, so I can go ahead and put 0 as my first coordinate. If I plug 0 in for x, that means that this term is gone, and so the only thing I'm left with is negative 5. My axis of symmetry is still x equals 0. So I'm going to go 0, negative 5. Label. It's going to open up. My axis of symmetry. And then I forgot this on the last one again. But does this have a minimum or maximum? Well, we can see that there is a low point here, so this is a minimum. Okay? So what I'd like for you to do is, we're not going to go on to the second part today, because again, we've done a lot already. So we're going to finish the second half of these notes tomorrow, because this is a good stopping point for us. So what I'd like you to do is, I think you have 10 problems to do with these. So I want you to go ahead and start working on that, okay? Then, listen carefully, please. If you get finished with all 3 assignments that were given today, and you have already finished your quiz and turned everything in, Miss Leanne has a check sheet and you've turned everything in. Okay? Then we'll see you tomorrow. But listen, you need to finish every single page that you are working on. And Miss Leanne must check off on it before you can leave. Please don't do sloppy work and make sure that you get it finished. You may not leave early, so get that out of your head. I told you my students don't leave early from my class, even if I'm not there. Okay. Get busy. Do your best, please. And we'll cover any questions that you have tomorrow. I will be back. Please make sure that you are working together as a team as well if you have any questions, all right? I'll see you guys tomorrow.